Sorry about that.
Everything okay now?
Yeah. Everyone's hearing, right? Not hearing anything from them. I muted them. All right. Yeah, they're saying yes.
Okay, good. All right. Sorry about the delay here. We'll get through this probably a little faster if we can. Please feel free to contact me by email if you have any questions. There's always a lot of questions for new programmers. Obviously, the programming is what actually makes the robot do what you want it to do, and it's really critical to design and implement a good program for your robot. The first thing that has to happen is to get the software installed on your computer. Most people like to use a laptop for their programming environment because then you can take it around to the tournaments and everything. The installation actually comes in several different stages. The first is a set of disks from National Instruments that provide a foundation for the whole platform. And then for C++ programming, there's another set of disks called Wind River that you would install. And then for Java programming, which is the other environment that first supports, you can download NetBeans from the internet and install that yourself. And there's another procedure that will be documented online for getting the robotics libraries working under NetBeans. In any of these environments, once you do get them set up, it does take a long time, but once you do, there are often updates available on the First Robotics website, so you'll want to watch for those and always keep those up to date. The other thing that's real critical in programming is getting your local network set up. Every team gets its own little private network, which is based on the pattern of 10.teamname.x. And you can see this example here, which has been hacked up a little bit due to the changes that have taken place over the years. In the early years, we had a router, which has been now replaced by a new bridge that has an access point, so we don't need the router anymore. Old teams, veteran teams might have one of these still and still be using that. Also, in the early years, the camera would attach directly to our computer. This is called a C-RIO, compact reconfigurable input-output device, and now they don't connect it to that anymore. They connect it directly to your bridge, which will make the camera feed faster. Those are just some changes for this year. Again, the C-RIO is the heart of the system, and this year is new in that the C-RIO is a 4-slot C-RIO. The previous C-RIOs were 8-slot, and there are some other differences. We won't spend much time going through those. In order to get your system going, here's where I want to change to a different view. There's a program called the imaging tool that will be used to set up your C-RIO the first time, and it will connect to your C-RIO. In the previous picture, you saw the wireless configuration, but when you're setting up your C-RIO, you do want a direct wire to it because you don't want to take a chance of losing connectivity while you're doing that. The C-RIO provides all the information the imaging tool provides all the information about the C-RIO that it finds. It shows a nice little map. This is new this year that shows what your C-RIO looks like and which slots are installed and that they're installed correctly. There's also, on the previous year's C-RIO, there are a bunch of dip switches that you can set, and those would be the state of those would be indicated here in the lower left corner. For the new C-RIO, those switches are gone, and they're strictly soft switches. You can change them remotely through this imaging tool. But the idea is that you would select the language of your choice, and you would want to format it the first time, and then click Apply, and it'll do its thing. It takes a long time, so I won't give you a demo, but this is the imaging tool. Now, the next thing you need to do is actually start working on a robot program in the language of your choice. This slide presentation was designed for C++, but the same idea will work in other languages too. And I hope we're going to have time to give a Java demo as well. So here again, I would rather actually show you the application. This is the Wind River C++ environment, and in order to start a new application, it's typical File, New, Example. It's a VxWorks downloadable sample. There are lots of different samples to choose from, and a good one for beginners is probably just a simple robot template. That's a good foundation that we've been using for years, and it's a very good place to start. Then the system will build up a foundation framework of that simple template example. First thing you always want to do, and this applies to all three languages, is give it a unique name. If you leave it as simple template and want to make it another one, then you'll get a conflict with the name. So if you right-click on the name, it gives you all the options. You can change it to something more meaningful, like that. Now, then you can open up your code through this navigator here. The file is all contained in a single file called myrobot.cpp. You double-click it, it comes up in the editor. And I can't go through a full tutorial on how to use C++ here, but basically what this does is create a sample that contains a robot drive object, which provides a foundation for the different ways of driving a robot around. And in this case, a joystick object, which you need to actually control the robot. In this environment, you hold your mouse over something like this, and it'll actually give you more information about it. The other languages, I believe, do that as well. This part of the program is the initialization of our robot demo. In this case, we're setting a safety timer expiration to 100 milliseconds, 0.1 seconds. We're creating a robot with 2 axes of control and a joystick based on the USB input 1. There's a built-in function for what to do in the autonomous mode, which is 15 seconds at the beginning of the game, when no operator control is allowed. This simple example just drives the robot for at half speed, straight ahead, waits for 2 seconds, and then stops. Then operator control is the function that runs during the rest of the game when the drivers are actually in control of the robot. And this simple example uses a single joystick to drive in arcade mode. So when you push the joystick forward, the robot will go forward, and you tilt it to the left or the right, and the robot will turn left and right. In any kind of a looping operation like you see here, it's important to wait for this 5-millisecond pause as a way of letting the motors update in the background while that's doing that. And that's a very simple program. And then the next thing you always have to do is compile it. You can there's a lot of different ways to launch a compile, but a right-click again gives us all our options, and a rebuild project will actually do the job of compiling. You can see the status down in the lower right console here. And now it's finished. If there were any problems, you'd see a big red indication here. For example, if I had some bad code in here and tried to build, there you go. Then you get all kinds of error messages that are very difficult to ignore. you usually want to find the first one and double-click on it, and it'll line you right up on those area of the problem. And it says crash undeclared. I don't know what it is, so we didn't really want that anyway. Next thing you have to be sure to do is stuff in the way of my menus here. Minimize a little bit. The next thing you have to do is be sure to set up the environment for your team. Under Window Preferences, there's a section called the First Downloader, and you enter your team number here. I have picked an arbitrary number of 4747 for experimental purposes. You would want to put your real number. In our case, it should be 1816. And then you use this browser to go to the location of that file that we just compiled. It's just a normal file navigator. Slash demo, simple template. Where did it go? There. I'm having some trouble finding this right now. Sorry about that. It's been a day where a lot of things go wrong. Should have been right in there. Okay, well anyway, normally that you would find your program in the path that assuming we could find it, the next thing you would want to do is deploy it to your robot, and that's using first deploy. And that won't work in this case because we don't have a robot to deploy it to, but that's the technique that you would use. So that's it. Oh, I see what the problem is. It needs to be recompiled. Now let's see if it can work. Window Preferences. Well, there it is. Then you should be able to deploy it because at this point we would be able to connect. This little part down here shows us our connection. We can connect to the robot with that.
Comment is that you type in bash and slash.
Oh, yeah. Well, I was able to later go back and navigate correctly. The reason I couldn't find it before was that I had failed to rebuild after putting my syntax error in, and so the object wasn't out there. But later, when I rebuilt it, then I was able to find it in the normal way. Now you can see that we are connected to this thing, and there's a bunch of target things you can do with it. At this point, we actually could deploy the code using the first deploy, and that brings up a little scroll bar there that times through it. And now the next thing you always have to do in C++ is reboot it. And a really good way to do that is to use this reset connected target. Now, on the real robot at this point, you'd want to see what it's doing by connecting it to the driver station. We go back to this thing. Oops. The driver station is this device here that actually runs on a little netbook called the Classmate. You can also run the driver station on your PC, and we do have this one set up to run the driver station, so I'll just start it. There it is trying to connect, and you can see that it did connect. If you like to see the green communications in the robot code, veteran teams looking at this might be a little surprised that there's no e-stop here. The e-stop button will not be used anymore. It's been replaced by the space bar, which may require some getting used to for folks who have gotten in the habit of using the space bar to enable or disable their robot. That functionality has switched. You should use the mouse, which is what we always use, or if you like to use the keyboard, the enter key will enable and disable. The space bar will trigger an e-stop, and you'll have to reboot everything. But in this case, obviously, we are not able to drive it. We don't really have a robot here. It's just a C-reel sitting alone with nothing connected to it. If we had a camera hooked up, you'd see a camera image here. You could see inputs, outputs, drive, the motor control signals, solenoids, and other things are all available for display. When you're running a program and trying to debug it, there's a little area here where you can display user messages. And so that can be a convenient way of debugging. So, here's where we are on this. So we've built a project, we've downloaded it to the system, rebooted the C-reel. Yes, and for normal testing, please put your robot on block the first time you try to do anything with it. You never know if your program is going to take off on you unexpectedly. So if you've got it up on blocks and those motors start spinning, it's not going to crash through the wall or, worse yet, run into a person and cause someone to get injured. So putting it up on blocks is very important. And then the driver station, as I just showed you, you want to see that the green lights are on, and then to run it, you would enable it and try driving it. Debugging, the Wind River does have a debugger built in. We have generally not used it, preferring to just observe operation and use text messages, such as I indicated, that you can put on the driver station. There's also a serial port, RS-232 serial port, that you can use to connect a console up and look at text messages that way. Not very many people do that, though. And at this point in previous demos, I have gone through a code sample, but I think I'll refrain from that due to time constraints. You can look at the sample really quickly and see that it's just a matter of changing a call to arcade drive and use tank drive instead, and add another joystick. Instead of a single joystick, you'd have a left stick and a right stick. So it's pretty simple to make a change like that. Let's see, here I commented on a few changes for the 2012 season. I showed you the imaging tool already. In programming, we're used to using slot numbers to identify the module that different sensors and so on are connected to, and that is not the way it's going to be done this year. This year, each module will be channel number 1 instead of slot number 4, say. And if you put another one of the same type in, that one would be channel number 2. And again, the other things I pointed out, such as the camera and plugging into the bridge instead of the C-reel, and no e-stop button. Not quite ready for questions yet. What I would like to show you next is just an example of what a similar program would look like for LabVIEW programmers. I don't have time to go through the process of starting it because it takes a while in LabVIEW, but that same type of a program, which in Wind River looks like this, while an operator control drives the robot in arcade mode from the joystick. In LabVIEW, it's pretty much pictures. You have a drive control icon. You feed the drive motors into it, and you read the joystick using a get icon. This contraption is called an unbundler, and it allows you to retrieve the joystick axes or buttons from the joystick and feed them into this thing, and then it just automatically drives it. And so that's how a LabVIEW program would look. And last but not least, I would like to bring our Java programmer in to give a quick demo on how to create a Java program. Alex.
Hello. Okay, so Java is very similar to C++. So first off, you have to create a new project, and there's usually default templates that come with the WPI-lib, which you download from the first website or first forge. So you want to select the simple robot template and choose next, and you want to call it something to remember what it is, I guess. And just me, I like to change the main class name. You don't have to, but. Okay, so once you have your project, you want to go navigate into the SRC and then into the package for the code and double-click on your main class. Now this is just a bare-bones class. It doesn't have anything other than a simple import and some package declarations. So one nifty trick that I learned early on last year is that you can put an asterisk where you can put your imports in the packages so that you can import multiple things, not just one thing at a time. So you have to declare your robot object, just like in C++, it's a robot drive object. I'll just call it Debug because that was our last year's robot. And in the constructor, you're going to declare the motors that you're going to be using. The method I'm going to be using today only requires 2 inputs, but if you use Mechanim drive, it requires 4. And you're also going to want to declare a to hold the joystick. So you just type in joys, and you call it whatever. Usually last year we used gamepad, so I'll just call it gamepad, I guess. And you make a new one. And in the constructor, you just give it a number so you can distinguish between joysticks. So that's the basic of getting user input and setting stuff to the robot. Now you have to actually get the input from the joystick, so I'm just going to make 2 variables. One to hold the left stick value, which will equal get so when you're doing the get raw axis, instead of just doing the get x and get y, because the gamepad has 6 different axes, you need to specify which of the axes you want. So by putting in the number, you're specifying which of the joysticks you want to get the input from. And I'll just do the same thing here for the right input. And of course, you're probably going to want to tinker with it a bit because I'm not quite sure if these are the right numbers. Okay, so now you want to set the values to tank drive for, well, I'll be using tank drive for this demonstration, but you can use either arcade drive, Mechanim, or Mechanim drive or tank drive. So for tank drive, you say what your robot is, and then you do dot, and you go to tank drive. And that being smart as it is, flips in the stuff for you. That's nice. Okay, so this is the basic code, but I've forgotten one major thing, and that is the loop in operator control. If you were just to run this right now, it would only go through it once and it would stop. So you want to make a while loop and have it use the functions operator control. And is And now you're going to close that up in the loop. Got that. And there we go. And of course you want to comment this when you're done, but I don't really have time for that. Okay, that's basic Java code. So give it back to Mr. Walter now.
At this point,
Somebody asked a question, where does the code that print F work?
Oh, yeah. So usually when you're debugging, just to make sure stuff happens, you're going to put print statements. So you just do system, for Java at least, system.out.print. And so you get all these different options here. So you can just do print, print lines, or print F. It's in there somewhere. But the difference is just how it prints out the statement. Print lines will give you a carriage return after it, meaning that, start a new line for you, and that's what I usually like to do. Printf is good because it gives you kind of like a format for the string that you want to put out, and then values which you can put in, and then a print is just like a print line without the carriage return. So let's do a print line here real quick. I'll put in there like starting.
that's where it actually gets displayed. You go to what's called the console, and when you're connected to the Ethernet port, the console can be fed back to your environment. I think it shows up on the right column there.
It does. That is configurable in the thing, but when you hit the run button, the little plus thing, it'll show you a display here, and it'll show up where this stuff is happening. So right now it's just building it and trying to connect to the robot. You do. So let me just stop that real quick.
While he's doing that, they asked what other platforms for C++ are commonly used. They use WinDriver.
WinDriver is the only one. The three platforms that we've just shown today are the only choices we have. WinDriver for C++, NetBeans for Java, and LabVIEW is always its own environment.
So you do have to set up your team in the Java, and that's under Tools. You may have seen it already, but the Tools Options, and you go over to Miscellaneous in the top, and then FRC Configuration. And then you use whatever team number you are, and you don't have to worry about this. It's usually just defaulted.
Okay, this one, 47, 47, you actually want to try.
I think it's formatted for C++, though, right?
Oh, yeah. The C-REO is set for C++, so we don't want to change it.
Okay.
It was stated that it takes a long time to re-image the C-REO, but how long is long?
When you do a full reformat, it's upwards of, you guys have watched me do this, right? So it could be up to 10 minutes, 5 to 10 minutes. And when you're just switching, once you've got the image on the C-REO, and all you want to do is switch between, say, Java and C++, that just takes seconds.
Okay. Is there any other questions on the code that I can clear up? Or are there?
How do you initiate a compressor in C++?
Okay, well, it'd be pretty much the same as Java. Do you want to do a compressor on that?
Yeah, sure. So a compressor, just as the other objects at the top of your code here, you're going to declare it. So
And it should take 2 inputs, right?
yeah, it should take
And one is going to be an input for the pressure sensor that will cycle it on and off, and the other one is the relay output for a spike that will actually turn it on and off, engage it and disengage it.
I guess this would be a, oh, sorry. Okay. This would be a good time to go over the constructor of this program. Just like in Java, or just like in C++, you want to make a constructor. to hold. There are some things in Java that you need to declare in the constructor and set up. So you just have to make another function called the same function as this class right here. And so, for instance, if you want to have safe code, you're going to do Debug, which is the robot, and then do set safety enable. There it is. And you're going to make sure that's true. That's just a standard safety option for all FRC robots. And then to start the compressor, you just name your compressor, and you just do dot. And then it's just, fire and forget.
Yep. The compressor, once you got it started in the constructor there, you never have to think about it. It cycles automatically throughout the rest of the game.
So the question was, so for the compressor, you just use new compressor and stuff like this?
Well, in Java, in C++, let me do a quick demo on C++. It's very similar, but you really don't need to use pointers in C++ because everything can just run statically. So I would suggest just doing compressor, how do you spell it? Or comp to make it similar. Now, it gets initialized down here in C++. And then initialized here in the constructor. There it is.
Are there any tips for reimaging the C-Reel when there's a problem?
That's a good question. I kind of wish our King Tech guys were still here because they've been having that very problem with their beta testing. There's a safe mode that you can go into that is supposed to put it in a default case that lets you get another shot at it. That safe mode is not quite working for the folks at King Tech, though. Let me see if there's a way to do that. Do I have my? Yeah, see the switch here called safe mode, and when you've got it in that mode, I guess it gives you more. It's kind of like the safe mode in Windows. It just starts a bare minimum that lets you check certain things out without a lot of clutter. And the C-Rio does the same thing. And then I think you can also connect through the serial port once you have this console connected. If you use a serial port, an RS-232 connection, that's always a really easy, reliable way to get some information about what's going on your C-Rio. Hopefully, with safe mode, you should still be able to get something off of your Ethernet, which would be easier because then you can look at it with your laptop instead of directly with a terminal on your laptop instead of a serial port.
Okay, so if not in safe mode, the IP address, what if not in safe mode, the IP address is not recognized?
Well, that's the cool thing about the imaging tool is that it doesn't care about IP addresses. You shouldn't have to worry about IP addresses with the imaging tool. It only looks for if there's a Ethernet connected between your C-Rio and your computer, and your Ethernet is enabled, it should find it and detect its MAC address, and it shouldn't care what the IP address is. That's the imaging tool is strong enough to be able to do that. And if it isn't, then you've got other issues. But yeah, you got to make sure that you've got your settings at least sort of correct. What we like to do. Wow, that's slow.
Is that a crossover cable?
No, it does not have to be a crossover cable. That's the cool thing about modern laptops is that they detect it automatically. If you've got a really, really old laptop, you might need one, but I don't think so. On the older configuration, we used to need a crossover between the camera and the C-Rio, but I don't think you need one anymore going through the the router, but it wouldn't hurt. So the general configuration for
Don't change any of that stuff.
I'm not going to change it.
We already
Plan for it anyway. The only thing I goof up is our serial. You pick up an IP address with 10.user team name. 5 is a good one for the whatever computer is the driver station. Any other number. Oh, nowadays you do not want to pick 11 anymore. 11 is the camera. So it used to be anything from 5 and up was fair game, but now you have to exclude 11 from that list because 11 is dedicated for the camera. But this is all you need to do to set up something that should be able to talk to your serial.
There is a conversation about when to use LabVIEW versus other ones on there. I think it's pretty much answered, but you can give your opinions if you want to.
Right. Each language certainly has pros and cons, and the decision of which one to use can be very personal. It can depend on prior knowledge. If the students have already taken Java in classes at high school, they might want to stick with Java on the robot. If you're looking down the road at wanting to be a professional, getting a computer science degree and programming for a living, I'd suggest the C++ because it's everywhere. LabVIEW is really good for visual learners, people who you could probably, you can see the program visually better, so a lot of people like that. It's not as widely used in the industry, but it's a very powerful environment and it offers a lot of functionality. It can do a lot of things really well, such as multitasking. You can put a couple of different things that you want the robot to do all in one little box, and it'll just automatically do them all at the same time appropriately. That kind of coding is a little more difficult to do in C++ or Java. I have a bias towards C++ because I've been programming in C since 1986, and so it's something I know pretty well. But I would not discourage anyone from whatever choice makes more sense for them.
If you have any other questions, please unmute yourself and ask the question. All right, that's it. We'll wrap this up.
Okay. Thank you.
So that'll be it. Thanks everybody for being patient and helping us through with our problems. The next one is Thursday night, 5:30. We've got 3 more sessions that evening. And then we're on again next Tuesday, 5:30 again with 3 more sessions. We will be posting these